Hi everyone, Kevin here with Wine 3 Lab. We're going to talk today about testing sulfites by Ripper analysis. There are several methods of testing SO2, or as we term it usually, sulfites. The simplest method that we do in Wine 3 is the Ripper method, and we'll talk about that in this video. You can use an aeration oxidation method, often thought as a little more accurate than Ripper. We do that in Wine 55 here at Santa Rosa Junior College. And we also do enzymatic methods in Wine 55. So you'll get those latter two methods if you take Wine 55. Today we're going to talk about Ripper. Ripper is a simple titration. We did a titration when we tested titratable acidity. And you'll remember we looked at a video. And that was a Khan Academy video, as you remember. Just so you know, I also have a video out there about titratable acidity. So please have a look at this if you need to refresh your memory about how titrations work. Today we're going to talk simply about Ripper. So how does the Ripper titration work? Well, it starts out with a burette, just like we had in the titratable acidity assay. And that has some graduations on it. And we fill it up with a solution of known concentration, just like we did in titratable acidity. In this case, the solution of known concentration is iodine. And the concentrations happens to be 0.02 molar. And we're going to drip that iodine into a wine. So we have wine in our flask like we did before. In this case, the iodine reacts with the sulfites in the wine. And we add iodine until all the sulfites are consumed. So the iodine reacts with the sulfites. And we add iodine until all the sulfites are consumed. So how do we know when all the sulfites are consumed? We need an indicator, just like we had an indicator in titratable acidity, that tells us when the reaction is done. And the indicator in the Ripper analysis is starch. And that's like starch from a potato. When iodine is added to wine, it reacts with the sulfites first. When the sulfites are all consumed, then the iodine reacts with starch. And iodine plus starch equals a black color. So as you get toward the end of the reaction, you'll see black color starting to appear. When you drop the iodine in, you'll get a black color appearing around the drop, and then it'll go away, just like a pink color appeared around the drops in titratable acidity, and then the pink color went away. We're looking for the black color to remain for 20 to 30 seconds, like we looked for the pink color to remain. And that means all of our sulfites have been consumed. So how do we know the concentration of sulfites? We take the beginning volume on our burette and say we titrated down to here. We take our ending volume, and the difference is the iodine used, and we measure that in milliliters. So little m, big L. In the lab manual is a formula that we use for calculating the concentration of sulfites. And what you'll need are two things. You'll need the concentration of iodine, and we're going to use 0.02 molar. And you'll need the milliliters of iodine used in the titration. Plug those into the formula. You'll need the volume of the wine as well. So the wine sample in milliliters. Plug those into the formula and you get the amount of sulfites in the wine. So, very simple, right? A couple things you got to remember. A couple things that we add to the procedure. First of all, remember that there are the three different species of SO2 in wine. We have molecular SO2, we have bisulfite, and we have sulfite. So those are the three forms of SO2 in wine. We said that they all constitute SO2. They're like three different models of Ford F-150s. They're all Ford F-150s, but you might have XL and SE and SEL or whatever the different model designations are. Our three species are all SO2, but they take different forms in wine. And the difference is the number of protons attached to these different species. So we talked a little bit about that in the wine chemistry lecture. The key for Ripper is that what reacts with iodine is only the molecular SO2. So that reacts with iodine. So one other step that we have to perform in preparing our wine sample before we titrate in the iodine is we're going to add acid. So we add acid, and by adding acid, that shifts all of the SO2 species into the molecular SO2 form. So we add acid, and we add sulfuric acid, and usually we add it in the form of 1 + 3 sulfuric, which means 1 part sulfuric and 3 parts water. So when we make it up, we take 1 part sulfuric, or actually we take 3 parts of water and add to it 1 part sulfuric. Okay, and that's just to dilute the sulfuric so it's safer in the lab. All right, so we add that acid, it shifts all the SO2 into the molecular SO2, and then we can get an accurate reaction with iodine, and all of the amount of SO2 will be accurate. Okay, so that's good. Now, one other thing that we have to do, and that is we have to consider the fact that SO2 is in both the free and the bound form, right? Remember that total SO2 is made up of free and bound forms of SO2. And the free, meaning it's not bound to any other molecule, the bound meaning it's bound up in acetaldehyde, or sometimes it's bound to pigments molecules in the wine. Acetaldehyde, it binds more tightly than pigments. But what we want to do is measure both free and total. What I've described to you so far measures free. All right, the bound SO2 in the procedure I showed you so far is still bound. So when we measure the way I showed you, even including adding the acid before the titration, that procedure gets only free. We have to do a separate assay. So we'll do one assay for starting out the way I showed you, and we'll do that for the free SO2. We're going to do a second assay, and we're going to do it exactly the same, except we're going to add one step at the beginning, and that is to add sodium hydroxide, and that will free the SO2 from its bound partner. All right, we add 1 molar SO2, so it's about 5 times more concentrated than the 0.2 molar we used in titratable acidity. We add 1 molar, and we wait 10 minutes, and then we do the same procedure as above, except we add some additional 1 + 3 sulfuric. All right, so I'm running out of space here. Add extra 1 + 3. And the reason is we added a strong base in the form of sodium hydroxide. So we have to add more acid to shift all of our SO2 species into the molecular form. It's the acid that shifts the SO2 into the molecular form. And so if we've added base, we need to add extra acid to first neutralize that base and then to shift all of our SO2 into the molecular form. Okay, so that's it. So be ready when you come into lab to do this titration. I got one more thing to hopefully make this clear and prepare you for the final exam, and that is to compare the two titrations. So in titratable acidity, the chemical in the burette was sodium hydroxide. Right? That's the one we use to neutralize the acid in the wine. So the chemical in the burette, sodium hydroxide, reacts with the acid in the wine. And how we know the reaction is complete, in other words, how we know we've added enough sodium hydroxide to consume all the acid, is we add an indicator. The indicator in titratable acidity is phenolphthalein. In the SO2 titration, the chemical in the burette is iodine. And what does that react with in the wine? It reacts with the SO2. The indicator that tells us this reaction is complete is starch. I said that when the iodine has consumed all the SO2, there's no more SO2 left to react with the iodine, then iodine reacts with the starch and turns the solution black. So when the solution is black, we know we have finished consuming all the sulfites, and the amount of iodine we added will tell us how much SO2 is in the wine. In the case of the titratable acidity, when we see the pink color, we know the reaction was done, that the sodium hydroxide has consumed all the acid in the wine, and the amount of sodium hydroxide we added tells us the amount of acid in the wine. That's it. Thanks so much for watching. I'll see you in class.